Hello and welcome. Let's walk through this physics challenge on the board. In a measurement, it is asked to find the modulus of elasticity per unit torque applied on the system. The measured quantity has a dimension of, so we have this is dimension, okay, of, this is the dimension of mass, okay, capital higher case letter M to the A, then L to the B, T to the C. If B is equals to -3, the value of C is, of course, to be able to solve this question, okay, I'm going to write the dimension for modulus of elasticity and the dimension for torque. You know, torque can be measured as the product of force and the arm of a couple. All right. Then when it is modulus of elasticity, this can be expressed as, you know, stress per unit what? Strain. Okay, and the unit of modulus of elasticity is Newton per square meter. Yes, that is 1 Pascal equals to 1 Newton per square meters. Okay, so one thing is very important when it comes to how to solve problems like this. First thing first, we need to establish that a dimensional formula is a formula which indicates the relation between derived unit and fundamental unit. That is, a dimension is an expression which shows how and which of the fundamental units enter into the unit of the physical quantity. So which means the dimensions of the quantity on the right side of the dimensional equation, okay, must be the same as the dimension of the quantities on the left side of the dimensional equation, and that's what we call principle of homogeneity. So like I said, so first we need to find dimension of, write the dimension of modulus of elasticity, dimension of modulus of elasticity. Okay, now modulus of elasticity can be denoted with letter what? Y, or we can use E. Okay, so which means the dimension of modulus of elasticity, okay, will be the dimension of force, okay, divided by dimension of area, because the unit of modulus of elasticity is the Newton per square meters, which is also equals to 1 Pascal, because 1 Newton per square meter is equals to 1 Pascal. So the dimension of force, because force can be expressed as a product of mass, and that's a body's mass and its acceleration, okay? So for mass, we can say now mass is m, then acceleration will be LT raised to the power of -2 divided by L squared, okay? So that this will be m L to the power of -1. That is when we divide L, okay? When we divide, when we cancel L, we'll be left with 1 under. So that will be L raised to the power of -1. Then this will be T raised to the power of -2. So this is the dimension for modulus of elasticity. Okay. Now for torque, okay, dimension of torque, okay, that's tau, this symbol. So for torque, we have the dimension, okay, is equals to the dimension of force multiplied by dimension of arm of couple. Let me just write distance, dimension of distance. So in this case, for force, we have force to be mLT to the power of -2 multiplied by L, so that this will be mL squared T raised to the power of -2. So this is dimension of torque. So just like now, as we have it in the question, it is asked to find the modulus of elasticity per unit torque applied on the system. Okay, so then I'm going to divide this by this. So we have the dimension of modulus of elasticity divided by dimension of torque. That will be this guy, okay, m L to the -1 T to the what? Power of -2 over m L raised to the power of 2, then T to the what? -2. So when m cancel m, okay, n cancel n, t to the power of minus 2 cancel t to the power of minus 2. So in this case, we have L to the power of minus 3, which is same as 1 over L raised to the power of 3. So now let's go back to what we have here. So which means I can write this. Now we are giving m to the a, okay, L to the b, t to the c, okay. So this will be equals to, so on the right hand side, this is what we got as the answer. So we're going to have n to the 0, then L to the what? Minus 3, which is what we have here. B equals to minus 3. Okay, then t to the 0. So which means that because there is no t, okay, there's no dimension for t in what we got from here, okay. So which means a in this case will be 0, b is equals to minus 3, and then c equals to 0. So therefore, the value of c will be 0. I'll see you in the next video. Bye-bye.